good morning to one and all. Good morning, Sri Charan. Can you hear me?
Yep, I can hear you.
Okay, fine. So let me just introduce you. I will just take the 2-minute time. After that, I will hand over the session to you.
Of course.
So today is again, a great moment for us, because being a teacher, no moment then this is, I will say, special or auspicious for me, where I have an opportunity to introduce my own student who has reached to such an height. And this is a kind of, let's say, the blessing moment for us also, being an NITKN. So he's none other than Dr. Sri Charan Sankar Narayan. He is a senior applied scientist and team lead in human and machine learning at Amazon.com, USA. He received his PhD from Carnegie Mellon University in the Language Technologies Institute, where his research focused on building the conversational agents for collaborative learning and work. He is a recognized scholar in the applied artificial intelligence, especially in the field of AI for education, serving as the senior program chair for the AI for Education conference in 2025. His work has been published in education and learning science conferences such as AIED, LAS, EDM, ISLS, CESCL, as well as AI and NLP conferences such as AAAI, IJCAI, and Cooling. At Amazon, he builds AI for scaling workplace learning applications to upskill and reskill the second largest workforce on the planet. So once more, we welcome you, and I hand over session to you.
Thank you so much. Thank you. Can everybody hear me in the room?
We can hear you.
Okay, excellent. It's a proud moment for me as well. It's an opportunity for me to come and speak to all of you. I wish I was there in person, but again, thanks to Professor Mahendra Pratap Singh for organizing and giving me the opportunity to at least join you online. It's also, I think, appropriate that now I'm one of the last few presenters, because what I'm going to talk about today, primarily, you can see my screen.
Yeah, we can see your screen.
Okay. One second. Let me make sure I'm sharing the right screen. Okay. Yeah, so what I'm going to be talking about today is actually evaluation. Right, so you might have heard over the course of the workshop, and I hope you have you've had a productive and fun workshop so far. But part of the equation is also going to be how you evaluate safety critical systems, especially AI in that context. So I gave sort of a provocative title for the talk, right? So I'm sure all of you would have heard about AI potentially replacing humans, and I think this is one of the contexts where that is likely to happen last. We'll talk a little bit about why I think that's the case. But regardless, I think the title of the talk essentially is a question in a sense. So man versus as well as with machines. And I'll take you through a framework that we built recently to evaluate AI, especially in these high stakes sort of applications. The more formal title for the talk, so to speak, is trustworthy AI, right? And the formal terms for using humans as part of the AI process is a human in the loop approach, right? So we're going to try and use humans in the loop for creating metrics as well as for evaluating model efficacy. And I'll try and pepper some examples throughout that hopefully helps you understand the context. And towards the end of the talk, we'll also have sort of a hands-on session. I'm going to try and figure out how to facilitate that, but we'll see. So regardless, I think you'll have an opportunity to do this as a take-home exercise as well. So I will share the slides with the organizers, and I'll give you a link where you can go and download all the materials I'm going to be sharing today in the talk. Okay, so yeah, so just quickly to start off with some resources. The core research paper that I'll be drawing from in today's talk is an upcoming research paper in the ICHKAI workshop on user-aligned assessment of adaptive AI systems. So the title of the work is Transforming Expert Insight into Scalable AI Assessment, a framework for LLM generated metrics and user calibrated evaluation. So I'll have a copy of the paper in the participant folder that I will be sharing as well. And I have some articles that I think are really good beginner guides and also deep dives. So for instance, each of these articles has deep links. So the more you want to know, the deeper you can go, essentially. So these are sort of good starting points, and then you can navigate and learn more and more as you go through these. And I really like this article from Anthropic. It clarifies what you mean specifically by agents and what's the difference between agents and workflows. Workflows are typically deterministic. Agents are dynamic, determining interactions between AI at runtime. And it talks about various architectures for AI agents that have been tried so far and could work for your use case as well. This one, I think, is incredibly relevant to this workshop. All of you should go and listen to this entire episode. This one is from this podcast called This Week in ML and AI. It's a pretty popular podcast. Some of you might have heard of it already. So the episode 705, I think, came out last year. But Lucas Gafsky is a pretty well-known expert in machine learning models, specifically for safety-critical systems. So it takes you through validation, evaluation in much more detail than I will cover today. We'll talk a little bit about the black box problem, and I've linked an article related to the black box problem as well. So I just quickly made a tiny URL link. I think the only thing I put there for now is the presentation slides, but like I said, I will put all these materials in there as well. Okay, cool. So today's agenda, I wasn't sure of the background of the participants. So we will start with the basics of LLMs really quickly. And then that leads us into why LLMs offer both a promise as well as concerns from the standpoint of AI safety, right? Then I'll introduce the framework that we've built. It's a pretty generalizable process, so hopefully it's understandable. I'll try to make it as simple as possible, and then we'll work through a few examples together. And finally, I've got a couple of hands-on exercises, and then depending on the time, I will leave some as as homework. My turn to give homework to people. Anyway, yeah. So that's just that's the way the talk's going to go for today. Yeah. So let's start with the premise, right? A really quick introduction. And I have sort of fun tidbits that I can throw in here and there. So hopefully for folks who already know about these aspects and these concepts, you'd still learn something new maybe. All right. So AI, I think broadly, it took a long time for me to come up with a definition that still works today. So I'll explain why. So broad concept, machines able to carry out tasks. And the phrasing is incredibly specific in a way we as humans would consider smart. This is because AI systems and the expectations from AI systems are reset over time as more and more things become commonplace, right? So if you think about it today, you ask your phone to set an alarm. When AI was in its initial stages, that would have been considered artificial intelligence. It would be an expert system that's essentially taking all of the information and deterministically setting an alarm, but it's still doing an activity on its own and therefore considered intelligent in that context, right? So back then that was AI. Now we've sort of gotten used to those. Those are commonplace. Even things like GPS, we wouldn't consider AI anymore. So human expectations are constantly reset as technology advances, and what's considered AI. In fact, the Turing test, as you might know, is at least in its initial formulation, unfortunately insufficient to determine intelligence anymore. Like, it used to be considered the hallmark, and now we've learned it's insufficient. There are language models that can beat the Turing test, but intuitively, as humans, somehow we recognize that they aren't intelligent, right? So, yeah, it's just an interesting tidbit. Of course, the subset of AI that allowed all of these transformations to happen was essentially machine learning, and the underlying idea is learning from data and large amounts of it. And of course, there's a compute revolution that's happening simultaneously that enabled this. And as you might have seen in the news, NVIDIA recently became the world's most valuable company. So not a coincidence that machine learning and the hardware revolution took off at about the same time. Finally, you get to the language models that specifically are driving this, I would say, this batch of AI progress. So that's what underlies technology like ChatGPT, right? Similar idea, but massive corpus of text and data, and specific model and specific way of modeling the data enables them to essentially understand and generate human-like language. So I'm qualifying all of these, right? Understand in quotes, generating human-like language. So ultimately, it becomes a philosophical question whether they're actually understanding. But from the standpoint of utility, right, are they able to instruction follow? If you can consider instruction following sufficient for understanding, then yes, LLMs have come a very far way in instruction following and generating human-like language. Okay, so how do they actually work? In a very basic sense, it's a prediction engine, right? So it doesn't necessarily know or understand. And this is another, the asterisk here is another qualification. There's plenty of debate, philosophical debates around whether models can reason, models can be intelligent. What is intelligence? What is consciousness, right? They'll leave that to the philosophers. But ultimately, it's a mathematical construct. So therefore, there isn't knowledge or understanding in the human sense, at least. However, it does work by calculating what the next token in the sequence is, right? And it's using patterns it's learning from all of the data that it's trained on, the massive amounts of data, right? Very simple example, cat sat on the blank, right? Probabilistically speaking, some tokens are more likely to occur next than others. So the cat might be sitting on the mat, on the couch, on the floor, so they're all fine. But cats sat on the moon might be highly improbable. The interesting piece is you can have a context where cats sat on the moon could be probable. So think of maybe a fiction novel or something, or a poem written by somebody. So the surrounding context also can affect what the next sequence in the next token of the sequence is. And that was part of the innovation behind transformers, which we'll talk about in the next slide. And of course, the big idea is that it's doing this at massive scale. Stringing to the most likely words from huge corpora of data. So under the hood, all the words, concepts are being converted into high-dimensional vectors. So these are embeddings. And the mathematical representation makes it easier to capture semantic relationships, right? So you can do math to determine essentially how close together they are in this embedding space, and that allows you to do some vector operations. So for instance, vectors that are closer together in the space are more semantically similar, right? So it's a convenient mathematical representation. Now, like I said, the big innovation is being able to pay attention not only to the sequence of words that came before, but also the surrounding context. And part of the innovation that allowed models to start paying attention to those surrounding context elements are self-retention mechanisms. So those are what go into the transformer architecture. That's the T and GPT, right? And ChatGPT. So transformer architecture really kickstarted this round of innovation in large language models. Cool. Important piece, we'll touch on this a little bit again. The output is probabilistic, right? So we already saw in the example that multiple things could fit in the next token of the sequence. So how do we determine the one? You might you might choose the best one. You might be greedy and essentially choose what the most likely next word in the sequence is. But if you've used your autofill on your phone, you'll know that quickly ends up resulting in some incoherent sentences. So you'll still have to care about whether the direction that you're heading is going to lead to a coherent thought, a coherent sentence. So anyway, over time, the idea is the output is probabilistic. So each time you sample from the outputs, you might get a slightly different answer. And not necessarily, right? So you can fix the answer if you want, but the idea is, generally speaking, the output can be output is always probabilistic just because you're sampling from the output sequence. Okay, so what's this black box problem, right? So plenty of AI systems have the black box problem. The LLMs are somewhat interesting. The black box problem can be sort of described in two ways, and I'll try to talk about the first as well as the second. So the big black box problem is that the model's reasoning is not intuitive to understand, right? So you can't simply look at the layers that are being activated, or although people are trying, certainly, it's hard to explain why the model came to a certain decision that it did just because of the complex sequence of nonlinear transformations across billions of dimensions in vector space that the model is undertaking for each generation. So it's not human interpretable. So specifically in the context of safety critical systems, the implication here is you can't necessarily ask why and get an answer that is verifiable and auditable, right? So that's the sort of big black box problem. So what will our goal be then? So in terms of evaluation, so we don't necessarily have to map every single neuron. Like I said, you don't have to trace the logic through the network. All we need to do is make sure that the behavior is verifiable, the outputs are trustworthy, even if the mechanisms are opaque. So we can treat the models as black boxes, right? However, we do want to evaluate the outputs such that we, as humans and as stakeholders in these safety critical systems, can gain confidence in the verifiability, auditability of these outputs, repeatability, consistency, whatever other factors are relevant, right? The other black box problem is that a lot of the best performing models are closed source, right? So Gemini Pro from Google, Anthropic Claude, all of these models are closed source in the sense that even if you wanted to try and trace the reasoning through the model, you don't necessarily know the model architecture, or you don't necessarily know the model weights. So they're not open source models. Of course, you do have open source models, right? So you have Llama and you have Mistral. I'd say those are the two top competing open source models, at least for text generation. But ideally, you want to use the best performing model, and often the closed source models end up outperforming the open source models, although they do tend to catch up over time. So you do want to use the best performing models. You don't want to be held back by having to use an open source model. So can we build an approach that essentially can treat the AI as a black box but still produce this verifiability and output? Okay, so the promise, like, what's the point? Like, why are we trying to do all this? Of course, then it needs to be worth the effort, right? The potential is pretty enormous, and this has been fairly evident for several years. I think there's many different companies that operate in this space that have been using traditional machine learning and AI algorithms. I think GE is a good example. Berkshire Energy is a good example in robotics, and even in maintaining trained cars and aircraft repairs and all of those sorts of contexts. Uptake is a company that I'm aware of, founded by the co-founder of Groupon, and they essentially work in a very similar space. So there have been plenty of folks who've been working on using machine learning, traditional machine learning algorithms, where essentially you collect a whole bunch of data, you try to build a custom model, and apply it to this use case. So the potential has been known for quite some time, and what language models offer go a little bit beyond what's been possible so far with traditional machine learning models, and even in terms of speed to market, ease of building the solution, right? So all of those things also matter. So anomaly detection, these are fairly, it's almost outliers in this context, and the idea is to supplement the knowledge that a human team would have with data from sensors and additional inputs, and use machine learning algorithms to comb through incredible amounts of data to try and come up with anomalies and hazards before they happen, right? Similar sort of idea, it's failure prediction, right? And I'm trying to be consistent with the examples that I provide. So I'm going to use maybe the energy domain as sort of my example. Transformer pipeline valves before it happens, right? So you can do proactive maintenance, or you can replace. You can order replacements. You can predict how much you'll need. You can predict where you'll need it. So there's all sorts of applications, and from a cost as well as safety perspective. And of course, the optimization, I think you might have heard from a couple of other speakers about this as well, the across the grid. And of course, speed finally. So latency, and being able to quickly get the inputs that you need in human readable form, right? That's another huge advantage with language models. You can interact in natural language and receive outputs in natural language. So anyway, that's the promise, right? So that's the value add. That's why we are going through the effort of actually trying to use these systems, even though we know that the downside exists. And what's the downside? It's the challenge for my workshop topic, which is the promise has to be borne out, but the systems are black box. So like we've established, it's hard for humans to simply ask why from the system and essentially get a response that's verified and auditable. And so it's a bit of a paradox, right? So how can we confidently hand over control, especially in these safety critical contexts, when we do not have the confidence that we're able to fully audit and verify these outputs? Okay, so now that I've established sort of the scope of the problem, I'll try and introduce the framework, right? And this is a fun example, and I'll talk you through. So how would you resolve the paradox, right? So there's promise from the language models, and then there is this paradox. And ideally, if you resolve them, then it can lead to really good outcomes in context. So my pitch, and again, researchers don't necessarily agree, and not everybody agrees, but humans, I would say, are the ultimate decision makers. And humans, unlike robots, have accountability, right? And I'm going to use this really famous quote from IBM. I want to say in '86. So really appreciative of them, back in the day. From a slightly different domain, but trying to convey a similar idea, right? So a computer can never be held accountable. Therefore, a computer must never make a management decision, right? Sort of a similar idea. A computer can never be held accountable. Therefore, it must never make a safety critical decision. So my pitch is these systems are augmenting and enhancing and really accelerating what humans can do. And humans remain in the loop and are the ultimate decision maker in the arbiter. So that's the pitch. That's how I'm going to try and resolve this paradox. Of course, there are other ways to resolve the paradox. One funny but way it's being attempted is replace all the humans. Have the bots talking to the other bots, and the ones handling the systems are also robots. The ones doing the decision making are also robots. So anyway, there's other ways to resolve the paradox, but my pitch is that I'm going to try and resolve this with humans in the loop. Right. So, so you've got these standard metrics. Right? What the challenge now is, how do we quantify what humans need from these safety critical systems in order to, one, be confident in their performance, and two, augment and improve the performance of the system as a whole. You've got these standard metrics: precision, recall, accuracy. You might have heard of all of these and been familiar with it, but just to quickly go over it. Recall essentially is, have I, in my pool of selected samples that I've flagged, have I gotten as many or all of the intended samples? Precision is, in my small pool of samples, have I only gotten the intended samples, even if there are other intended samples that I haven't captured, right? So these are ways of understanding, sort of quantifying the requirements, and depending on the system, one or the other can be important, right? So maybe in a system where you would much rather, right, it's an incredibly hazardous system, and you would much rather get false alarms, right? It's okay to have false alarms. All it requires is somebody to check, just make sure nothing's wrong, and then come back. Then you would prioritize recall. But if it's sort of a system where the cost of doing a false alarm is very high, right, then precision might be important. You only alarm when you're incredibly sure that something's gone wrong. So yeah, so these are pretty traditional quantitative metrics, but what we're trying to capture in the language model context is well beyond that. We're trying to capture utility of these systems, right? So there's some human expertise involved. So maybe, again, keeping with the grid example, let's say there's a seasoned grid operator. They have sort of an intuitive understanding of what makes an alert useful. So they're receiving alerts all the time. What makes it useful, right? Is it timely, clear? Does it point to the root cause? Now, how do we take something like that, their intuitive understanding of what a good and useful result is? How do we transform that into metrics, right? And then how do we use those metrics to evaluate language models and contrast the performance of the systems that we build? Right. So what we can easily measure are quantitative metrics: accuracy, precision, recall, like I said. And what the expert will truly value is utility, right? A model that's almost close to 99% accurate, but which misses the catastrophic event, will be a failure. That's sort of the fundamental gap. Right. So I'll try and introduce this framework fairly quickly, and then we'll do maybe a hands-on exercise. Okay. So general problem is now, how do we turn these expert intuited qualitative metrics into quantitative ones, right? So that's what we're trying to do. So we go through 4 different phases. And like I said, it's a generalizable process. In terms of techniques, you can really apply a whole variety of techniques, but I'll try to keep it as simple as possible and as fundamental as possible. And y'all can use your knowledge, skills, and creativity to plug the machine learning components in the right places. So the first step, obviously, is eliciting the requirements from the experts, right? So you choose experts that are part of your safety operations, and then you have them help you define what good looks like, right? Then you use that corpus of data that you've collected, your subject matter expert inputs, and you can now, again, feed this into an LLM and ask it to come up with a set of concrete measurable rubrics. So part of what you're trying to do is ask it what metrics are based on the expert feedback, what metrics are even relevant in this context, and what scale those metrics will be rated against, and what each item on the scale corresponds to, right? This is only the start, so you don't have to be perfect at the very beginning. Then what you use is, again, another set of LLMs. This paradigm is called LLM as a judge. So you use a bunch of LLMs to now go and rate and apply. So you've come up with the metrics or an LLM has come up with the metrics. Now another set of LLMs is going and applying them on the actual outputs at scale, right? And then you can come back and you can calibrate, right? So once the outputs have been rated, you can ask the experts to also rate using the same metrics that you've developed and see if they align. If they don't align, you can ask the expert where the misalignment is, right? So this maybe step one is quite difficult, right? There's this notion of what's called expert blind spot, right? All of you might be familiar with it, right? Many of you know how to ride a bike, how to swim, but teaching others is very hard because you over time intuitively understood how to do it and you've forgotten what it's like to be an amateur trying to learn how to swim or trying to learn how to ride a bike. So it is a hard process to go to an expert and ask them to describe what good looks like. So step 4 helps with it, where you've essentially given them the outputs and now say rate the output. That's much easier to do, right? I can rate an output as good or bad. I may not be able to describe. So both 1 and 4 work in tandem to actually elicit feedback from experts, right? So, and then you can repeat this process over and over again. And again, we'll go to very specific examples, and I think you'll understand how the process works. And like I said, you can like really use any off-the-shelf model to do this as well. But of course, if you have a lot more data, you can consider techniques like fine-tuning the model or further model distilling. And any other techniques that can improve the performance, latency, size, hosting requirements, whatever the case may be in your context. So I think this is pretty small, so I might try and zoom in and show you the parts of the process, right? So just look at the bottom, so just look at the top box for now. The AI system outputs a set of metrics. The LLM as a judge applies those metrics, and then you get a score, right? And then there's a parallel evaluation happening here where the human expert evaluates the output. They provide a score as well as a rationale, and then you calculate whether those two are aligned. If the alignment is greater than a threshold that you've set, then you can actually monitor and deploy the system, right? If not, you can identify the discrepancies between what the experts are rating and what the LLM is rating. And then you analyze the expert reasoning. Again, I'm saying you, but all of this is done automatically by LLMs. And you can refine the metrics and definition, except, of course, the human in the loop box. Everything else is done by the LLMs, yeah. And then you can update the prompts and continue the process over again. So hope that makes sense. It's fairly simple. The process itself is fairly simple, but of course, the important idea here is, one, eliciting these requirements from humans who are part of the process, converting those requirements into metrics, right? That's the biggest challenge. Human interpretable metrics, right? And then 2, continuing to calibrate these metrics over time. 1, as requirements change, and 2, as experts get more nuanced understanding of what they need from these. Okay. So let's try a few of these hands-on. I might not be able to hear the room, but let me. I'll pause after each one, and we'll try to spiritually understand each other and make progress. Like I said, I'm gonna share this slide deck with the workshop organizer, so you can try this later as well. And there'll be a lot more details and a lot more technical specifications in the paper that I can attach. Okay, so now it's your turn, right? So your mission is to calibrate or help me calibrate the AI judge. So you are an expert evaluator. So we're going to do a simplified version of the expert calibration phase. So in this case, the AI is issuing some alerts, right? So it's processing a bunch of information from the system and producing alerts that a human is now supposed to read and action on. We will assess those alerts on a couple of metrics that we've generated, right? So your evaluation will ultimately be the quote-unquote ground truth, but unlike, let's say, a traditional classification problem, we're not requiring you to rate this as positive or negative. It's much more nuanced than that. And you can give open-ended feedback as well. Oh, this is wrong because blah. Right? So that's again another advantage of natural language inputs in language models. Okay, so the problem is an anomaly in the grid, right? And we've come up with two metrics already based on some initial expert feedback. One's called time to detection, right? That makes sense. So how long did the AI actually take to flag the issue? And we'll measure this in seconds. The other one's a little bit more interesting. It's what's called actionability score. So how actionable is the piece of alert or piece of feedback that the AI generated? Maybe on the lower end, it's completely useless. It's just an alert. It gives me zero context, right? Somewhere in between, it tells me what's going wrong, but maybe not what, maybe not why, or maybe the location is unclear. The score of 5 will be the best, right? So you have enough information to take immediate action, and it only tells you what is absolutely needed in that moment to take action, right? Nothing irrelevant. That's another part of this. Okay, so let's try and do this together. So the event begins at t equals 0 seconds, right? Transformer to substation delta is beginning to overheat. We'll see a few of these AI responses, and we'll try to rate it on the accountability scale. Okay, first example, right? It says alert at t plus 90 seconds. So it's taken 90 seconds to actually produce this alert. And it says anomaly detected at substation delta, right? Pause, think for a second. Hopefully it's obvious. Be on the lower end of the scale, right? The exact rating may be, arguable, but this is among the worst. So I'd say I'd give it a 1. Sure, it's flagging the anomaly, but no additional information. Maybe the substation is identified, but not the exact location. So even if I need to action on this, it's a lot of effort, right? So the next one, it's a little bit faster. And now it gives me the specifics of what the anomaly actually is, right? It says high temperature anomaly. And then it actually identifies the location. So this one's a little bit more useful. And depending on my experience, I might be able to figure out what the action is as well, right? So I have dealt with many of these high temperature anomalies maybe, and even maybe dealt with the same unit having failed multiple times, so I know the exact action required. But it can be even better, right? So think about the last one. It provides exact information about what the high temperature anomaly is, right? What the cause might be, so likely coolant leak, and what the recommended action is. So this is much more, it's useful for somebody who does not have the experience that the person in the second example had. However, keep in mind, this might also be sort of a downside, right? Because it's, especially if you're trying to elicit action in the next minute or so, just the volume of data that you're reading through, parsing, and then actioning on can't be too high either. A really good practical example of this happening, of course, is the nuclear reactor meltdown in Chernobyl. They had alerts for everything, but when all of them are going at the same time, it's incredibly hard to figure out what the root cause is. And seconds matter in that sort of context. So you don't want to overwhelm as well. So we might have to come up with a more nuanced definition. So how do we do that? We provide feedback on this and feed it back to the LLM to compare and contrast between the ratings that the humans have provided and the ratings that the LLM has provided. And when there's a mismatch, look through the feedback to actually understand why and recreate the metrics. You can add additional metrics if needed, or refine the definition of the existing metrics in the scale on which they're rated. Okay. So anyways, the lesson we've learned is time to detection is important, but it depends a little bit on the criticality of the anomaly. In the example we've chosen, maybe it's very critical to get quick get the alert as quickly as possible. But there may be other contexts where it's much less urgent, right? Maybe you have a monthly replacement of a filter. Sure, as the date approaches, it might start to become more and more critical, but just a reminder to order a filter or something a month ahead of time is good enough. And then actionability has a few different components, right? So what is the anomaly? What's the source of the anomaly? What's the cause? And what's the recommended action? So we've talked about this, but yeah. So let's look at a quick calibration loop, and then we'll look at another example. So this one, the AI judge rates as a 4 out of 5, but the experts are saying it's only a 2.5, right? And it's sort of a similar idea where the type of anomaly is not mentioned, so I can't really action on it. So maybe the location's fine, the timing is fine, but type's not mentioned. So this will allow us to go back and since there is a mismatch between the expert calibration and the AI judge, the LLM is going to look at the discrepancy and the reason for the discrepancy and now be able to update the definition of the metric. In this case, it will say, okay, if you need to score a 4 or higher, you have to have the type of the anomaly as well. So that makes the future assessment much smarter, much more aligned with what users need and these experts are needing in real world. Okay, so let's try and define a new metric entirely, right? So I'm calling this resilience. It's kind of an interesting metric, but we can start with a very vague definition. Again, the part of the value of the process is not where you start, but all the feedback that you're able to gather and update along the way. So you can start as naively as possible. So the model should handle unusual data, noisy data, right? Now we're going to try and do pairwise comparisons. It's another way of gathering feedback, right? So again, we're trying to, when we work with humans in the loop, the biggest challenge is being able to elicit the inputs that you need such that it's useful for the AI model. So a couple of ideas I talked about before. One was just asking, that might give you a bit of a start, and then showing examples and asking the experts to rate them and explain why they provide the certain rating or not. And the final one is pairwise comparisons. And you might have experienced this if you've used ChatGPT. Once in a while, they run experiments where they'll produce a couple of different responses and ask you which one you like better, right? So that's what's called learning from preference feedback. And this is sort of a similar idea, where now you can show two different models and their alerts, and then essentially ask which one is better and why, right? The first one's not showing any alerts. It's dismissing subtle changes as random noise. The other one flags a low confidence alert. So it does provide a confidence indicator. So it's not a high confidence alert, a very low confidence alert, but it does provide this coordinated anomaly detection pattern. So in this context, maybe the expert is fine, right? They understand that it's a low confidence alert. So if their expertise allows them to intuit that this is something worth following up on, they can definitely do that. And of course, you can adjust the threshold over time if this is spuriously firing, again, similar to precision and recall, but it's in a custom defined metric, right? So all of that's possible through expert feedback and calibration just automatically. Yeah, so the expert feedback is that, and then we feed several such expert feedbacks, and then we get this V2 version of the resilience metric, which is, it can detect weak and correlate patterns across multiple data sources, distinguish between random noise and systemic issues, as well as appropriately identify the confidence level of the decision that it's made. Yeah, so that's sort of the idea, right? So again, back to my pitch, especially in safety critical systems, my trust is that the future is collaborative, at least near to midterm future. We'll see about the long term. No one can predict that far out. And our goal is not only effective safety AI, but also be able to have a model that can assess the outputs of the AI and produce trustworthy, and who's the one who has to trust as the humans in the process, right? Both the experts as well as the humans who are touched by the outcomes of these models. Yeah, so the very maybe tough example, but let's say a self-driving car is quote unquote making a decision to crash into somebody because that ended up being the most unavoidable thing it could do under the circumstances. we need to have the ability to be able to explain the decision that it made, and at least understand that as humans, there wasn't anything that could have been done, and therefore this ended up being the action that the in that case the model took, right? So it's relevant in many different contexts because humans still continue to be consumers of the AI at the very least, if not participants in the process of creating it. So yeah, then as AI penetrates more and more applications, explainability ends up being paramount and often left by the wayside. So it's important, and I like that this workshop's focusing on this aspect. It's important to enforce that over and over again. Yeah, anyway, we've talked about all of these, and I've included just basic specifics, but I will include much more technical details in the paper. So big key takeaways I want to try and leave with you is that we need to move beyond simple metrics when we're trying to capture expert feedback and use those as metrics to evaluate AI models. And I've presented a framework to do that. It's not the only way. There's several other attempts to do similar things, but I think it's a pretty simple and easy to follow process, and you can plug and play components of the system with more complex LLM algorithms if you have the data and the compute resources and hosting and latency requirements and things like that. The LLM as a judge concept, it's with leveraging to do this at scale, right? So once you have the metrics, you can really deploy evaluation at scale, especially once they've been calibrated with the expert and the LLM is able to produce close enough ratings to the expert. You can run the system independently with audits once in a while to make sure it continues to stay aligned with the expert. So again, it's not about replacing the human experts, but it's about codifying their wisdom and then collaborating with them to build trust. Like I said, the humans remain consumers of the products of AI systems. So explainability is going to be important now, important in the near future as well. Okay, I'm going to stop there. Hopefully that leaves enough time for questions. I can talk about a few more things, but I think we can pause here. I leave my email ID. Hopefully it's easy to remember. It's sri@cmu.edu. You can find me on LinkedIn. If that's your preferred means of communicating, that's perfectly fine. And of course, follow me on Google Scholar for all of my latest publications. All right, so I'm going to stop sharing and we'll see if there are any questions in the room that I can answer.
Recently, I heard from another professors like you in India. They were struggling hard to identify the difference between money bank and river bank. So you undergo self-attention, so many other things, train the transformer, and then try to find out that through language model only, once again, addition of words. Instead of that, if you can really see the picture of a river bank and a money bank, if you make the LLM to read the images, some bypass, and then come back to that will ease the situation. Multimodal LLM.
Absolutely. Yeah. Yeah, there are. Go ahead. Sorry.
That will really help multimodal LLMs.
Yeah. I agree. So that's sort of the idea behind multimodal LLMs, right? So, there are many different kinds of multimodal LLMs, but there's at least one set of models where the goal is to simultaneously take image inputs, voice inputs, sensor inputs, along with text, and that it's a very similar idea, like what you're saying. Like intuitively, you're trying to understand it. It's essentially the same vector embeddings, right? Now, instead of just word vectors, sentence vectors, or phrase vectors, you've got additional vectors that you can use to get context, right?
Yeah.
Part of the issue, again, it's not an unsolvable issue, but part of the issue is the image information is much more complex, right? And it's representation is slightly different, right? So word, we can decompose it into tokens. So a word has a meaning, and a combination of words has a meaning. A sentence has a meaning. When you try and decompose an image into pixels, might not necessarily have meaning, right? A single pixel is a color, 2 pixels, still something, right? Convolutional neural networks, when they first came into the picture, tried to do pattern identification in images. So what they would do is the early layers of the convolutional neural network would identify circles, squares, that kind of shape. And then maybe the later layers will be like, okay, 1 circle and then 2 of these is a cat. 1 circle, long sphere is a dog, right? So it'll try to put these fundamental shapes together to try and identify what the actual image was. And these large language models are doing something similar, where they're trying to put together these relationships in vector embedding space, and augmenting text with image data, like you're saying, absolutely makes it easier. But computationally, it is harder. So it's always a, while training, it's a much bigger, much more complex data set. Once you have the model, it's more powerful. But again, runtime, you have to do all of the same calculations once again with the data that you're providing as an input. So slower. All of this matters in your applications. You'll have to figure it out, whether you have, okay, I don't care if I wait 2 minutes, I want the best answer, or I have 2 seconds, and I need, or even 0.2 milliseconds, and I just want what you can deliver in that time, right?
Yeah, that's very good. And in addition to that, is some other computer scientists have done. They have used Hilbert space for identifying the pixels, and because that vector space is much robust, and you can go for that. I think mathematics may be the better answer.
There's an interesting angle to take with this is also hardware. You might design hardware specifically to process these representations, right? Plenty of companies are trying to do this. Google has tensors, right? Matrices, it just so happened they were being used for graphics, as we know, right? It just so happened to also be helpful for machine learning. But tensors are a slightly better representation. And so Google came up with tensor native hardware. Now companies are trying to do training specific and inference specific hardware. So Amazon, for example, has Trainium and Inferentia. So those are like the 2 chips that are trying to build with hardware specific to those representations. So that's another angle you can absolutely take. And I think India is pretty well positioned to at least go that direction, especially the amount of investment that's happening in semiconductors. And definitely look at this space.
Professor, the first slide that you showed.
Hang on, sir. I just want to correct you. I'm not a professor, just a doctor. The professors are sitting in front of you and behind you. Please. Thank you. Doctor is enough, but just call me.
Shri. I will call you Shri. Shri,
yes,
the first slide that you showed was very nice, because although I have sat in so many lectures, the way you described the first 3 paragraphs of AI, ML, and LLM was very, very nice. I really appreciate that.
Thank you.
Now, I saw in your slide that you have been affiliated to Language Institute at CMU, right?
Mm-hmm.
So I don't know what that does, but one of the problems that I have been grappling is how to teach English to rural students in India.
Fun. Yeah.
Okay, and this word prediction in LLM seems to be the answer, or it looks like very interesting thing. Imagine the LLM at slow motion. That means I don't want the LLM to put out the word unless the human is given a chance to tell it himself.
Yep.
Okay, the cat sat on the dash, and I want the student to tell first moon or couch or something, and then the LLM gives out. So I want a LLM in slow motion with the specific purpose of teaching students how to speak English. So can you throw some light on this?
Yeah. I can talk you through a few different methods. So so the traditional LLMs, as you know, they're trained to be very helpful, very nice. So they'll give you the answer, right? But a lot of the major language model companies have come up with a mode in language models called Socratic learning, right? ChatGPT for Education has this. Anthropic has this. Socratic learning, it's named after Socrates. And Socrates, the way he was teaching his students was by asking questions, right? So you ask a question, he won't give you an answer. He'll ask you another question. And then the question is obviously meant to trigger something in you. You ask another follow-up question, and then it goes back and forth like that. And simply through a sequence of questions, you're getting to an understanding because you're asking better and better questions over time. So that's the idea. The implementation is very similar to what you were saying, where the model can offer a few attempts for the student, right, to get the right answer. Each time they make an attempt, the model might say, oh, it's wrong in the specific way. And you can tune the level of feedback you want to give as well, right? So from an instructional standpoint, in the initial phase, you might want to give them a little bit more support, right? Okay, I will tell you, maybe try once, try twice, I'll tell you. Second time, okay, I'm gonna make you work a little bit harder. Then over time, okay, so now that you've internalized the understanding, I can actually give you the solution and the reasoning and all that. So absolutely possible to build these models. It's off the shelf, like I said, Socratic learning mode in ChatGPT for education and Anthropic Claude for education. Just Google Claude for education or ChatGPT for education. You can use those. And as an academic, you'll have some free access to that, so you can definitely give that a shot. And then you can, of course, build on top of it with your own.
Just an extension question.
Yeah.
I am less a researcher, but more a product development.
No,
person.
absolutely. I'm strongly encouraging you to go try it. You don't need to be a researcher. That's part of the value
So
add.
there are two products. Like one is RapidX English speaking course. Other is this Duolingo. Okay.
Yep.
So now in the age of LLM, can there be a new form of language learning application which will be better than Duolingo in many different ways?
Yeah, so I guess I'll go back to the initial question you asked about what the Language Technologies Institute was doing. The founder of Duolingo, Louis Van Aan, is from Carnegie Mellon, used to sit like above my office. And Duolingo itself, controversially, has switched to using language models. So to answer your question, the next version of Duolingo is Duolingo itself.
Oh, okay.
Controversially, right? So we consider Duolingo as a language learning app, but for the most part, it was more of a social community building practice and activity sort of tracking app. And a lot of the users did not want to pay if they're being provided support by language models instead of humans, right? And they fired a lot of their human translators. And so there's a huge backlash right now from the subscribers of Duolingo. So maybe they'll walk it back. So that's another interesting sort of human AI conflict situation. But anyway, point is, yes, it can be. That's always been the promise in language models. What I would like you to think about, though, is the languages that what are called low resource languages. Unfortunately, a lot of languages we speak in India. So I speak Tamil, Kannada, and of course you're in Mangalore, so there's Tulu, Konkani. None of those languages are represented on the internet. You forget about Tulu, Konkani. You just think about the largest language, Tamil, right? Is considered from a natural language processing standpoint as a low resource language. Why? The internet doesn't use Tamil script, doesn't use there's no Tamil. I mean, there is, but of course, in quantities similar to English or Chinese or Japanese or Spanish or any of those languages, high resource languages. So the tact that you take with trying to learn a language like English, which is a very high resource language, is going to be very different from the tact that you take to learn a language that unfortunately is low resource. And that becomes an even bigger challenge in the modern world, because all of our languages, of course, are struggling, right? And we would ideally like to keep that alive, the literature, the history, the culture. and teach our next generation those languages. And in order to build language apps that can support that, you have to take a completely different approach, because the amount of data that you have is much lesser than you would in the other scenarios. So anyway, complex answer, but
sorry for taking a lot of time, but
Not-
I'll
not
just
enough.
harp up on the earlier question, and like
Yeah.
what my friend told was multimodal. That means when you actually learn a language, apart from the script, if you are shown the river bank or the money bank, it will definitely be easier for people to,
No,
recall.
so language learning is, you can go even a step further. Language learning is immersion. Immersion means you go, if you want to learn Spanish, dump yourself in Mexico and try to figure out where the toilet is, ask, how to eat. That's the best way to learn. And the other way to immerse yourself without being in the context is watch movies, without subtitles. Start with subtitles. That's a way of quote unquote scaffolding the learning, right? So you have some support when you hear the words and see the meaning, and then slowly fade the subtitles away. So over time, you'll be automatically learning. Anyway, so those are other, pretty popular, pretty well-defined techniques for learning language, which unfortunately Duolingo doesn't emulate, which is part of why I don't necessarily consider them a language learning app. Funnily, and Professor will attest to this, my Hindi is not that great, okay? And in the Duolingo has Hindi है Duolingo में, और मैं प्रयत्न किया. See, my Hindi is terrible, and I automatically tested out of the entire Duolingo suite. So you can see, if I'm able to reach proficiency in their Hindi language learning, and I cannot conversationally speak Hindi comfortably, then it's a question of whether it's actually a language learning app or not. So anyway.
Yeah, thank you.
Just adding more flavor because you have some religious background. In 7th century, 8th century, one Jain saint has written a book. I forgot the name of that book. I have to log into my WhatsApp and then go through and then tell. If you go in a linear fashion, you will get one language. If you go in another fashion, you get the second language. Like that, 50 languages can be used. In that Lipi, he has written like that. How about making use of such things and developing?
Yeah. So actually, those sorts of similar ideas are what are being used to train on these quote-unquote low-resource languages, because there are some parallel texts you have. So one good example is the Bible, right? A Bible has been translated to pretty much every language on the planet, right? So you have parallel texts. So you have the same word and the same word represented in multiple languages. So those are sorts of corpora that you can use to gather at least the vocabulary of and the words that are used in the language. And then, similar to what you're saying, you can use situational uses, right? There have been texts that are written in the past where, for example, Ashoka's edicts, right? So they have written it in multiple languages. In Pali, it's in the local language, it's in Sanskrit. And so you have parallel translations like that, which you essentially use as corpora for these low resource languages. Because again, it's a very labor intensive process of collecting data, but that's what we're doing, right? We've shown already the data, the more data we have, the better. And we're trying to get data from as many sources as possible. So yeah, very similar ideas are being used. A couple of companies are working in the space that I'm aware of in India, Indus, and they're trying to release these language models. Like I said, it's effortful. So somebody really has to, I'd say Monojit Chowdhury's lab in Microsoft Research in Bangalore, they do really good work on low resource languages specifically. So they organize a workshop as well, a yearly workshop. And I think you should get you should participate in the next one for sure.
Professor has one more question.
Sorry, can you repeat the name of the lab in Bangalore?
Monojit Chowdhury is the name of the person. It's Microsoft Research India.
Okay.
The topic is low resource languages.
Okay.
So you just put low resource languages India, you should be able to find them. They're pretty top researchers in this specific field.
Yeah. Good morning, Sri.
Good morning. Yeah.
Yeah, yeah.
12 hours time difference. It's
Yeah.
almost bedtime. Yeah.
Actually, I want to know that is there any framework uh, available for trustworthy assessment already available, or it is just a initial phase where you are thinking that human intervention is required to uh, set the accountability of the or responsibility of this judgment. Even we have seen one example, their machine judgment is comparatively better than the human collaboration's judgment. So are we not limiting the full potential of the machine?
Yeah. So 2 questions. Let me answer the first one. Trustworthy frameworks, it's still the beginning stages, I would say. There's plenty of workshops being organized in explainable AI and user-aligned AI assessment. Of course, the models themselves, I think Anthropic is a good example. They've come up with this model called Claude, and they aren't giving you the raw weights of the model. They're applying a couple of layers on top of the model that has some safety features built in, right? So if you ask, for example, how to build a bomb, the initial versions of ChatGPT used to actually give you detailed instructions. So all of that has now been at least sequenced out, and these red teaming attacks, essentially, if cybersecurity, it's pretty common. So you try to apply the similar concept here. To answer your second question, it's interesting. You need to figure out what your priority is. Let me put it that way, right? In a way, yes, you're limiting the potential of the system. But if the system fails, right, who's going to take responsibility? So your trade-off is, let's say, in 99% of the cases, it's going to be much better. In the 1% of the cases, it's going to blow up the nuclear power plant, right? If that's the trade-off, then obviously, it's okay to limit the performance of the system and achieve this adequate balance. The other way to look at it is, over time, we will get more and more of this feedback and more confidence and more trustworthiness, more viability, more data. You can take more and more of these cases into automated hands. And it's very similar to self-driving trucks and cars, right? In the initial stages, they used to employ people to drive simulators, hours and hours and hours and hours of data. Over time, now you're only focused on the anomalous situations. Oh, there is rain on the road, and the reflection is showing the something else, and it looks like a person, right? So you're now focused on very edge cases. So it's able to do anything very typical, completely fine, fully solved problem. All these edge cases, it has to start training. So over time, again, the amount of work done by the human versus the AI definitely is going to change, right? So that's part of the paradigm.
Fine. Yeah. I also think it's depend on the sectors where we can.
Yeah, absolutely.
And criticality of the
Yep.
infrastructures.
Yeah, absolutely.
Thank you.
Hi, Sujit here.
Yeah.
See, about that BUM you told na before, it used to give the detailed description how to do that. In fact, very recently I have asked by giving a name, date of birth, place, a few of the things, mobile numbers, and ask it, give me a password. So it didn't give, which is earlier it used to give. So this, can we say, responsible AI?
Yeah.
And
Yeah. So yeah. Again, similar to the earlier question, it's either a pro or a con, depending on what you're trying to do, right? The reason it could, yes, I mean, your answer is yes, but I'm just going on a slight tangent. What I'm saying is, when you're trying to fudge with the outputs of the AI after you've done the process, the data-driven process, that might non-deterministically affect other outputs. The quality of the model overall might drop because you're trying to fix, essentially. So for instance, a common example is mathematics, right? Language models, like, at least initially, they're terrible. Even now, to that, for that matter, it's not great at math, just simply because they aren't doing math. They are trying to learn from the sequence and predicting the next token, and therefore next token after number is a number. Any number is fine. So it's gotten a little bit better, but most of it is band-aid solutions, right? So if you detect math, you trigger an agent. That's what ChatGPT does now. It'll trigger an agent to write Python code to calculate and then insert the out back into the sequence, right? So anyway, point is, yes, these are responsible AI improvements, but one needs to be cognizant of the unpredictable implications as well, just because of the non-deterministic systems. I think it's much better if in the data itself, data stage itself, the training stage itself, we're able to enforce these. It's just much more predictable in terms of performance, but yeah.
Yeah, thank you. One more, word of appreciation. I really like your, style of presenting and,
thank you.
depth of knowledge. No, really, it's good.
No,
Thank you.
I'm glad. Yeah. I mean, all of this we've learned from our professors. I don't know if he remembers, but he used to take 2 classes very often, 2 classes back to back. And just imagine being able to hold students' attention for that long, right? Especially at the NDK, especially class of 100 plus, right? So these are, definitely things we owe to our professors.
Thank you.
Thank you.
See, I appreciate you involving the human in the loop to validate a machine learning output. But I think a more important use of the human is to make a list of all possible anomaly cases, especially in self-driving cars. Why wait for an accident to happen to find out the anomaly case? We must crowdsource and find out a list of all the anomaly cases so that we can prevent an accident 10 years later.
Absolutely.
We are just postponing the problem. The rarity of the occurrence is low. That doesn't mean that it will not happen. We know for sure that 10 years later, one Tesla will crash somewhere. Okay.
Yeah.
So the list of anomaly or edge situations, I don't see anybody working on those or crowdsourcing those things. That is very important.
Yeah,
I
that's
feel.
an interesting idea. I'll tell you, there's sort of an underlying ethos actually behind your question, where a lot of researchers have gone completely on the tact of fully data-driven AI, right? No part of the process can be quote unquote an expert system, right? So what you're describing essentially is, let's collect all of these cases and sort of have this hybrid approach where, yes, a lot of the stuff it's learning from data, and then we also give it some instructions on how to behave in certain situations that we've collected data for. That is very popular, very effective approach in practice. It's a combination of both, right? What we know, what we're able to collect, plus what we're able to learn from data. It's just, I think the field in general, they've gone to the tact of, okay, completely data-driven, which means I'm not going to spend money anymore on paying humans to give me lists, paying humans to train. I'll just go and run simulations. I run 100,000 million simulations. It's going to be cheaper than paying a human to do it. In terms of performance, completely agree. It should be a combination of both these expert system style approaches plus these data-driven approaches. Again, I can't speak too much to what one company is doing versus another, but
See, I
agree with you.
I want to relate one experience which I had.
Yeah.
I was invited to an African country to give a lecture on mobile banking or something. It was a less known country, Ghana. Okay. After the session, it was a 2-hour session. They called me for lunch. Before lunch, I had to go to the restroom to relieve myself. Okay. Then I went there. There were 2 restrooms, one for men and one for women, but I didn't know which was what. Because the dress appeared similar,
Right.
the men's dress and the women's dress, and I was in urgency to go there. I didn't know what to do. I finally had to tolerate myself and wait for some human being to enter one of the restrooms. Then I could recognize which was the restroom. So imagine that when culturally, you will have different things. So you cannot expect the limited data set which US people use or Europeans use
Absolutely.
to expect to solve the third world problems. It will be a disaster.
Absolutely.
Okay. So I
Absolutely.
think we must expect disaster to happen. At least
Yeah.
if you give us a warning, it will be good.
No, like I don't know if you remember, Tata made an investment in self-driving cars in India, and a lot of companies are really, really interested in the Indian use case, specifically because one of the most complex driving use cases on the planet. Right? You can have hazards from anywhere. Unfortunately, you had NH66. Now you have you have pedestrian overbridges from one side of the campus to another. You have at least 2 bridges now. I didn't have that when we started, and people would cross the highway. Imagine national highway, human, human hazards. Of course, forget about cows and of course the road hazards. So India is actually an incredibly rich data set for plenty of use cases, including AI, because the kind of anomalies, the kind of edge cases we deal with would make any system robust beyond necessity. Right now, you can take that in any context and it will outperform. So yeah, there are a few companies that are explicitly trying to gather data in complex road environments. I think Tata was one of them. I haven't kept track of that project because I'm not too on top of goings on in the self-driving space, but I know for a fact that that was at least the motivation behind doing it in India. And again, for all of your research as well, all of you, I think there's plenty of rich context in India that you can really exploit to. Maybe exploit is a wrong word. Maybe leverage to further research beyond what's possible in other environments. Right? Even personally, like I'm pretty sure every single person in the room speaks at least 2 or 3 languages. Right? So you personally, when you in your brain context switch, which means you switch from Hindi to English or English to some other language, you're doing what LLM is trying to do, and it's parallel generating from one language to another. So language transfer, right? So what if you're able to somehow capture that data, and of course our linguistic diversity, nothing to speak of. So anyway, so there's plenty of other contexts as well where it's applicable. Yeah, in India is incredibly rich data-wise, and yeah, just need to be creative, put in that effort, can do it.
So is there any question from online participants? Srichan, we have some online participants also.
Sure. Yeah.
Yeah, it looks like there is no question.
Okay.
Okay. So it is an honor for me to have a student like you then, and now a great researcher, as well as you can say a great resource person
Of
today.
course, yeah.
And we all enjoyed your session. And you have.
Yeah, thank you. And of course, if you have any questions, if I can provide any guidance, again, I'm always available. I have gotten to this point through the effort of plenty of other people, right? Just like a neuron in the last layer of a neural network, who's depending on the weights of every neuron that came before it. It's plenty of people who've helped me when I've needed that help and answered my questions. There'll always be a resource. Of course, time is going to be the limited constraint, but I will try my best to give you support, or at least connect you with somebody who can, right? So please reach out if you have any questions, anything I can help with. Always happy to.
So it is great to have you with us today. And I am really thankful for you to accepting my invitation and taking this step forward to come and join us and share your expertise with us. So thank you. Thank you very much.
Thanks for inviting me. Thanks. It was a lot of fun.